Now let's talk about the popular words mining. Okay, mining. Let's say at the very beginning of a Bitcoin in the year of 2008, there is only one person who are in the system, Mr. Designer Satoshi. And Satoshi at that time was using one computer. We assume that's one computer in the year of 2008. Let's say that computer has a speed of 8 terabyte per second. All right, so that's a pretty fast computer at that time. And how could Satoshi get all this Bitcoin? It's easy as long as he could solve all these digits, okay, all these digits that for the header of the block, or we can call it the chain part of the blockchain, then he will succeed and get the 50 Bitcoin for each time he solved for every 10 minutes. All right, so let's see. I still have not said how many digits are in this chain, okay, or in n. So n equals to what? It does n equals to 2 or 4 or 26 or 200. If n equals to 2, that'll be pretty easy to solve. You can just guess, is that a 0, 1 or 1, 1 or 1, 0 or 1, 1 or 0, 0. So that's pretty easy to guess. You just try 4 times. But if you if the digits is a 4, so this is a 4 times. If the digits is a 4, then you're gonna try it 16 times. All right. And how much the n would be? Don't worry, the system has already generated for Mr. Satoshi and his follower bit users. Okay, generated by the system. And the rule here is the n will be the fixed number, will equals to a certain number, so that every 10 minutes there will be one blockchain built. All right, so in this example, Mr. Satoshi is employing a computer, runs 8 terabyte per second. All right, and then there are 60 seconds in a minute. And for each cycle of a blockchain, there would be 10 minutes per block. All right. So and this 8 terabyte would be 8 times 10 to the 12th bit, okay, per terabyte. So basically, you need to know how many digits are there. So 8 times 10 12th bit per terabyte, okay, multiply by that. And then you will be able to cancel some of this. Minutes canceled, second canceled, terabyte canceled. So the finalized number will be 384 times 10 to the 14th bit. Okay, so that's how much Satoshi's computer could calculate for each of the 10 minutes. All right, and that number bits is 2 to the power of 55. All right, so at this time n would be required by the system to be 55. All right, so in the blockchain, okay, in this blockchain you will have first 55 numbers as the header of the block or the chain, and then you will have 201 digits as the block. So how do I get a 201? So that's a 256, the digits in the function minus 55. So this is how I get a 201. So 201 digits in the block. Okay, so this is your blockchain. So all I'm saying here is when there's one computer at this speed, then the system will set the n to be 55. Okay, so to ensure that each 10 minutes passed by, there will be one blockchain built in the system. The system cannot set the n to be a smaller number, let's say 10, which is less than 55 in this scenario, because that's gonna make it too easy to solve for the blockchains, this 256 digits. So then the time will be less than the 10 minutes requirement. So this will not work. So this will not work because the time required is less than 10 minutes. And the system cannot set the n to be 66, which is greater than 55. Then in that case, Mr. Satoshi's computer would spend more than 10 minutes to solve for the blockchain. So this would not exist either. So the system has to set the n equals to 55 in order to keep the Bitcoin mining as planned. So now many years have passed. So not just Mr. Satoshi is mining, maybe he has retired, but definitely there are a lot of people in the system that are mining Bitcoin. So there is a big ocean of transactions. So let's say we have an ocean of Bitcoin transactions, and all these informations are coming up. Okay, this all new informations are coming up, and we have a lot of users are using their using computers to mine Bitcoin. So not just Mr. Satoshi, but everybody there wants to get the reward. What is the reward? As I said earlier, it is 50 Bitcoin to get a one blockchain in this years, and 25 Bitcoin in this years. And in the year of 2016, the price of Bitcoin has already raised to $10,000 each Bitcoin. So that's a lot of incentive for these guys to mine Bitcoin. So what they're gonna do is they first, of course, they need to collect the information for the block they are about to build. So they will get the information from the pool of information. You know, each person is employing a computer or a factory of computers, but they may have same information, they may have different information. They all get a piece of information from this big pool of new information, and they each try to build a blockchain. And then they each try to build a block. Okay. Well, the thing is, who would get the reward? Who would get the 25 Bitcoin? They all are competitors. So who will win? Then they have to all work on the first digits. They have to all work on the chain. All right, so let's say this is A, B, C, and D. And they all have to solve for the first digits, okay, of the chain. Right, 0, 1, 0, 1, 1, let's say. And whoever solve it first, then whoever get this number right solved first, then that person would be qualified to have his or her block connected to the blockchain system, and that person will get his or her reward of 25 Bitcoin. Okay, as you can see, they're competing not only to get the information from the the pool of information to build a block, but also they have to solve for the chain. Okay. If that is the case, then the person who employs the most computer or has the highest capacity of calculating will have this part solved. And then since there are so many computers are doing the work, then the system will make it harder to solve for the chain. So the 10-minute rule can still apply. So let's say if there's if in the world there are 10,000 computers, okay, not just A, B, C, and D, but a lot of other people are mining Bitcoin. And each computer, the speed equal to now 15 Bitcoin, 15 terabyte per second. Okay, so what's the computation power? Let's say every 10 minutes has 60 seconds. Okay, and each second, one computer can solve 15 terabyte of data. All right, and each terabyte is 8 times 10 to the 12th bit of data, and you have 10,000 computers. So the computational power here is, if you do the math, is a 720 times 8 to 10 to the 18th bit size of a beta, and that's roughly 2 to the power of 69. So that's how much the computers in the world can calculate in every 10 minutes to build a one blockchain, okay, for one blockchain. And then the system will set the n right here equals to 69, all right? As you can tell that if n increases, it is more difficult to solve, and if n decreases, it's easier to solve. And when I say it's solve, there's no best way of solving. You can just guess. You just guess one by one, and may the luckiest computer win. Okay, so whoever gets this digit right, then that person or that computer will win the Bitcoin prize. Okay, and once again, the n cannot be greater than 69, cannot be less than 69. It has to be exactly 69 to ensure the 10 minutes rule for one blockchain. So back to this previous illustration, we have 4 Bitcoin users, and they all speak binary language. And everybody not only need to build up their own blocks from this ocean of transaction information, also they need to solve for the chain to connect the block to the existing blockchain system. So let's say right here you have the existing blockchain. Okay, so everybody is trying to solve for this system generated chain, which is n digits of binary numbers. And A may just try from 0, 1, 0, and if it's not right, then he will try 0, 1, 1, so on and so forth. And C will try 1, 0, 1, or 1, 1, 0, keep trying that way. And D will try 0, 0, 0, 1, 1, 1, and then keep trying. And everybody is using their computer power to do this tedious work, try to solve for this chain of numbers. And then this person get lucky, Let's say this person get lucky and his computer and solve the number, and he will say, hey, I guessed right. So he guessed right, and then that basically qualifies him to put his blockchain. Okay, since he already solved the chain, he will put his block to the existing blockchain. All right, and then a new upgrade is made over there. And for these other people, for C, A, and D, they can still eventually solve for this chain of numbers. They can still get it right. But as long as B has it right, all of these people's work would be too late. Although they can solve it, but even though they solved it, it will be too late for these people, for C, D, and A. So this person will say, oh, bummer, too late. I can still solve it, but it's just too late. And too late means they cannot get the Bitcoin, because the Bitcoin is only awarded to the person who solved this problem. So Bitcoin goes to him. He is a winner. All right. So once the new blockchain is made, then everybody has to start over again. And this time the system will generate another chain of number. So this will generate another chain of number, 110, 1110, and so on and so forth. So still there will be n digits of such numbers. So this will be another chain. And then everybody will start over again. Okay, they will start guessing again, not just A, B, A, C, and D, the previous losers, but also the previous winner. He will join the new process. And then they will do another round of solving, which means they will guess this number with whatever number they start with, or whatever algorithm or calculation method they employ with. They just need to guess what will be the right number. And then this time, this person got lucky and he said, hey, my computer worked out and I guessed this number right. And then he will build his block, but this block will come from another new round of information. Okay, this is a new update put into the pool of information. And so everybody is working on a different set of information and get a different block. And this time, this person's block, together with the chain he just solved, will be built into the existing blockchain system. All right. So whoever gets the number right will be rewarded with the Bitcoin, 25 Bitcoin. All right, and then the system will generate another number, okay, for the chain. Again, it contains n digits, and then everybody will start over again, including the winner and the losers. Okay, so that's how the blockchain is built up. So how many Bitcoin could be mined in this system? Let's say for each 10 minutes, there will be one blockchain built. And for the first 4 years, each blockchain would be generating a reward of 50 Bitcoin. Let's say for every hour, there will be 6 blockchain being built. And then you have 24 hours in a day and 364 hours in a year. And you have 4 years. And then for each blockchain, you will get 50 Bitcoin. So that's what happened in the first year. And then for the first 4-year period. And then in the next 4-year period, the reward will be reduced to 25. So still the same rule applies. So that's how many blocks will be built for each 4-year period. But this next 4-year period, the reward per blockchain will be 25. And then you will have 12.5, and then you will have 6.25, so on and so forth. And if you add all of this together, although you have an endless amount of years, but the Bitcoin rewards will diminish into nearly zero. So the summation is, if you apply some mathematical technique, will be 21 million Bitcoin. So that's how much Bitcoin have been mined and will be mined in the future.